Okay, in this example, I'm going to find the point of intersection of the two lines given here, R1 equals and R2 equals. And to start with, as with any problem where I'm finding intersection, I'm going to begin by trying to solve these two equations simultaneously. So I start off by thinking I'm going to put R1 equal to R2 and see what I get. Now, of course, here, to equate these two, I equate the top components, the middle components, and then the bottom components. So I'm going to get three equations. Let's see what we get. 2 plus 6 lambda is equal to 2 minus 3 mu. Minus 3 plus 7 lambda is equal to minus 12 plus mu. I'm looking at the bottom components. 4 minus lambda is equal to minus 1 plus 3 mu. It's going to take a moment to tidy these up. This is going to give me 6 lambda plus 3 mu is 0. This one is going to give me 7 lambda minus mu is equal to minus 9. And this one is minus lambda minus 3 mu equal to minus 5. Call that 1, call that 2, call that 3. Now, what I want to do for these two lines to meet at a particular point, I want to find the value of lambda and mu that makes all of these true. So my next step is to pick any two of these and solve them. Now, looking at these, I can see that the mu components match in 1 and 3, so I'm going to solve 1 and 3. So let's do that. Solve 1 and 3. So I'm going to have I'm going to add these together. So I've got 5 lambdas is going to be equal to minus 5, lambda being minus 1. That tells me if I go back into one of these equations, I'm leaving 2 alone completely. I'm going to go back into equation 1, which tells me 6 lots of minus 1 plus 3 mu's is 0, so mu has to be 2. So I've got these values of lambda and mu, which I know work in 1 and 3, but I don't know about 2. So it's crucial at this point that I then check to see that if those values make equation 2 correct. So I'm going to check in the equation that you didn't use in the previous step. So I'm going to check 7 lambdas, 7 minus 1s, minus the mu, minus a 2, should be minus 9. Is that true? Minus 7 minus 2 is minus 9. It's true. What does that tell me? Therefore, they do intersect. So I know that they intersect. These values make all of these equations work. So now I can go on and find this point of intersection. So to find the point of intersection, I need to go back to one of the two original equations. I either use the lambda value in here or the mu value in here, and it wouldn't matter which. So if I go back to the equation for R1, R1 is going to be 2 minus 3, 4, plus lambda, which I know is minus 1, lots of 6, 7, minus 1, gives me the vector negative 10, 5. And the last thing to mention here is that if they ask you for the position vector, you've done. If they ask you for the point, you have to give the coordinates. So I'm going to say the point is at negative 4, negative 10, and 5. I found the point of intersection. Now, just to complete the example here, I'm going to add a little note that if I'm dealing with skew lines, lines that do not intersect, then that would become evident in this check step here. You'd solve two equations, you'd get two answers, but they wouldn't check out in the third equation. So for skew lines, they do not intersect, and the check step will not work. And that's how you'd show two lines are skew lines. Sometimes lines can be parallel lines. How do you spot that? Well, you would recognise that the two direction vectors are multiples of each other. So for parallel lines, we should be able to spot them. So for parallel, notice that the direction vectors are multiples of each